Curvilinear coordinate systems 11. A second toroidal system using coordinates psi, eta, and phi can be formed with these coordinates related to the Cartesian coordinates by this set of equations. Part A describe the surfaces of constant eta and constant psi and constant eta. So we will work on this part now. Okay, so for constant psi surfaces, here are the equations written again, the coordinate transformation equations, noting that psi is a constant. Psi is equal to psi 0. So that's what I have done here. And we're going to utilize this cosine hyperbolic square eta minus sine hyperbolic square eta is equal to 1. And also cosine square plus sine square is equal to 1 wherever needed. Okay. Now, from this equation here, coordinate transformation equation, we can write cosine hyperbolic eta minus cosine psi 0 is equal to a sine psi 0 divided by c. So this is what we can do. And for these two equations, I can take the square of x squared plus y squared. Now you can see that I have the same prefactor for cosine and sine here. So this will be cosine square plus sine square. Therefore, I will obtain a square sine hyperbolic eta square divided by cosine hyperbolic eta minus cosine psi 0 parenthesis square. All right. And so let me carry this equation here. So I have x squared plus y squared is equal to this. And also from this equation, I can write cosine hyperbolic eta is equal to cosine psi 0 plus, let's move it further, a sine psi 0 divided by z. So I have these two equations. Okay, so then I can rewrite x squared plus y squared. X squared plus y squared is equal to a squared now for sine hyperbolic square eta, which I obtain here, I can use cosine hyperbolic square eta minus 1. And cosine hyperbolic eta is given by this. So this is going to be a square. And then I will have sine hyperbolic eta square, which is this squared minus 1. So this is going to be cosine psi 0 plus a sine psi 0 over z parenthesis squared minus 1. And here I have at the bottom cosine hyperbolic eta minus cosine 0 psi 0. For this one I can substitute a sine psi 0 over z So taking the reciprocal, this becomes a z square divided by a square sine square psi 0. And now you can see that these a squares will cancel out. Okay. So x squared plus y squared is equal to z squared divided by sine square psi 0. Now opening up this parenthesis here, the first term is cosine square psi 0. Then I have 2a sine psi 0 cosine psi 0 divided by z plus a square sine square psi 0 divided by z square minus 1. The first term I obtain here is z square cosine square sine 0 divided by sine square psi 0. That is cotangent square psi 0 plus the second term I obtain here is 2a. Now sine psi 0, one of the sine psi 0s will disappear. I will be left with cosine over sine, which means this will be 2a multiplying z squared with 1 over z. I obtain z. 2az cotangent psi 0 plus this term a square sine square will cancel, z square will cancel, so only a square will be left. A square minus the last term, minus 1 multiplied with z square over sine square psi 0. All right. And this can be written in z square parentheses. Z square parentheses, I have cotangent square minus 1 over sine square. Cotangent square is cosine square. Cosine square over sine square. So cosine square minus 1 over sine square psi 0. Then the next term, 2az cotangent psi 0. Then I have a squared. Now, cosine squared minus 1, so this is going to be minus cosine squared minus sine squared, so cosine squares will cancel. Minus sine squared divided by sine squared will give me a minus 1. So this is equal to minus z squared plus 2az cotangent psi 0 plus a squared. Okay, so let me rewrite this. I have x squared plus y squared is equal to, take it into a minus parentheses here. This will be minus parentheses z squared minus 2az cotangent psi 0 minus a squared. And this is equal to minus parentheses z minus a cotangent psi 0 squared. This is going to give me z squared minus 2az cotangent psi 0 plus a squared cotangent squared. So it's going to be minus a squared cotangent squared to compensate for that new term that comes out, and minus a squared. This is what we have now. And I can take this z minus a cotangent psi 0 squared to the left-hand side. So this will give me x squared plus y squared plus z minus a cotangent psi 0 squared is equal to, operating the minus sign here, this becomes plus a squared parentheses 1 plus cotangent squared psi 0. And what is 1 plus cotangent squared cosine 0? 1 plus cosine squared psi 0 divided by sine squared psi 0. A sine squared plus cosine squared is 1. So I have a squared divided by sine squared psi 0. Therefore, I obtain the following equation: x squared plus y squared plus z minus a cotangent psi 0 parenthesis squared is equal to a squared divided by sine squared psi 0. So what is this equation? This is going to represent a spherical bowl. So we can basically identify this as a spherical bowl. These bowls are centered at x equals 0, y equals 0, z is equal to a cotangent psi 0, and they have radius a divided by sine psi 0. So this is how we identify constant psi surfaces. What about constant eta surfaces? Here are our transformation equations, again noting that eta is equal to eta 0, so it's a constant. So once again, if I write x squared plus y squared, you can see that I have the same prefactor here, so it's cosine squared plus sine squared equals 1. So I will obtain a squared sine hyperbolic eta 0 squared divided by cosine hyperbolic eta 0 minus cosine psi squared. And at the same time, cosine hyperbolic eta 0 minus cosine psi can be written by taking the reciprocal of this equation and taking the square root as a sine hyperbolic eta 0 divided by square root of x squared plus y squared. And that means I can write cosine psi to be equal to cosine hyperbolic eta 0 minus a sine hyperbolic eta 0 divided by square root of x squared plus y squared. Okay. And now going to the z equation for cosine hyperbolic eta 0 minus cosine psi, I'm going to substitute this. So for the z equation, I will obtain z is equal to a sine psi square root of x squared plus y squared divided by a sine hyperbolic eta 0. So I have replaced this by this, so square root of x squared plus y squared goes upstairs and a sine hyperbolic comes downstairs, as we can see here. And we have a cancellation of these a's, and we can write now sine psi is equal to z sine hyperbolic eta 0 divided by square root of x squared plus y squared. Okay. Now we know that sine square psi plus cosine square psi must be equal to 1. Now sine square is z squared sine hyperbolic eta 0 squared divided by x squared plus y squared. And for cosine psi, I have this. So I'm going to take the square of this plus parentheses cosine hyperbolic eta 0 minus a sine hyperbolic eta 0 divided by square root of x squared plus y squared parentheses squared. This must be equal to 1. Okay, so this is going to give me z squared, the first term, sine hyperbolic square eta 0 divided by x squared plus y squared. That was the first term. Now I have cosine hyperbolic eta 0 squared. Then I have a squared sine hyperbolic eta 0 squared divided by x squared plus y squared. Then I have minus 2a cosine hyperbolic eta 0 sine hyperbolic eta 0 divided by square root of x squared plus y squared. This is equal to 1, and I'm going to multiply this equation with x squared plus y squared. So when I do that, the first term will be z squared sine hyperbolic eta 0 squared. The second term will be x squared plus y squared parentheses cosine hyperbolic eta 0 squared. Then I have this term a squared sine hyperbolic eta 0 squared. Then I'm going to have minus 2a cosine hyperbolic eta 0 sine hyperbolic eta 0 multiplied with square root of x squared plus y squared, because this is x squared plus y squared divided by square root of x squared plus y squared, and that's equal to x squared plus y squared. Okay, now this is again z squared sine hyperbolic eta 0 squared plus x squared plus y squared parentheses let's see, we have cosine hyperbolic eta 0 squared minus sine hyperbolic eta 0 squared. So cosine hyperbolic squared minus 1 is equal to sine hyperbolic squared. So if I take this x squared plus y squared here, and I'm going to write cosine hyperbolic eta 0 squared minus 1 plus a squared sine hyperbolic eta 0 squared minus 2a cosine hyperbolic eta 0 sine hyperbolic eta 0 square root of x squared plus y squared. This is equal to 0 because I've taken this to this side. Now, as I have just noted, this cosine hyperbolic square minus 1 is sine hyperbolic eta 0 squared. So this will give me, in sine hyperbolic eta 0 squared parentheses, I have x squared plus y squared plus z squared and a squared. So x squared plus y squared plus z squared plus a squared sine hyperbolic eta 0 square is equal to 2a cosine hyperbolic eta 0 sine hyperbolic eta 0 square root x squared plus y squared. And this gives me the following equation: x squared plus y squared plus z squared plus a squared is equal to 2a. You can see one of these sine hyperbolics will cancel and I will be left with cotangent hyperbolic. So 2a cotangent hyperbolic eta 0 x squared plus y squared inside the square root. This is the equation of a toroid. Okay. The major radius is capital R. The minor radius, which is the radius of the tube, is lowercase r. Capital R square minus r square is a square. And this is equal to capital R. So this is basically the major radius of the toroid, a cotangent hyperbolic eta 0. You can see a drawing and some examples from this website here from Wolfram. Basically, this represents a toroid, and we're going to also play with this when we do part B using a Mathematica code. All right, now I have analyzed constant psi surfaces. I have substituted psi equals psi 0. I've analyzed constant eta surfaces. I have substituted eta is equal to eta 0. So I have done let eta is equal to eta 0. And have manipulated these transformation equations. So first I have written cosine hyperbolic eta minus cosine 0 in terms of z using the first equation. Then I have pulled out cosine hyperbolic eta in terms of cosine psi 0 and sine psi 0. And then I have looked at x and y equations. I have taken the square of the two and added them up, noticing that cosine square plus sine square is equal to 1. So I have obtained this equation. And for the sine hyperbolic square, I have substituted cosine hyperbolic square minus 1, where cosine hyperbolic is given by this expression. So after some cancellations here and noting cosine over sine is cotangent, I have obtained this equation. And taking this into z square parentheses, I've noticed that I'm getting cosine square over sine square minus 1 over sine square, this form, and rewriting it with a minus parentheses and noting that I have on the left hand side minus of z minus a cotangent psi 0 parentheses square, which is taken to the left hand side here. I'm left with a square 1 plus cotangent square psi 0, which is 1 over sine square psi 0. So this gives me the equation of a sphere. X equals 0, y equals 0, z equals a cotangent cosine 0 is the center, and the radius is a over sine psi 0. It's a spherical ball. Constant eta surfaces, I have substituted eta equals eta 0. First I've taken x squared plus y squared, and then from this equation I have obtained cosine psi, which is given by this expression. And using the z equation and substituting this result for cosine hyperbolic eta 0 minus cosine psi, I pulled out sine psi. Then I've noted that sine squared psi plus cosine squared psi is equal to 1. So square of this plus square of this must be equal to 1. And after some manipulations here and multiplying the equation that I obtained with x squared plus y squared, and taking the x squared plus y squared to the left hand side, I have noticed that here I obtain a cosine hyperbolic square minus 1, which is sine hyperbolic square. I have each of these terms having a sine hyperbolic square. So sine hyperbolic square parentheses, I obtain x squared plus y squared plus z squared plus a squared. And on the right hand side, I have, taking this to the right hand side, to a cosine hyperbolic sine hyperbolic square root of x squared plus y squared. After this cancellation, I obtain the equation of a toroid with a major radius a cotangent hyperbolic eta 0, and you can play with this using this website here, and we're going to elaborate on this more when we do part B.